As Eric and I have already proposed, our design would utilize digital scans of traditional city or highway maps, which renders the product into a form known as a raster map or image. Rasters are just a collection of square pixels. Those pixels are ideally used where certain colors represent different features. In this example, we can use blue for water, green for forest, yellow for marshland, and tan for grasslands. There are benefits to using such a format. However, using just a scan of an image or traditional map, the color functionalities of this raster are not applicable for navigational purposes. The positional layout and traditional representation of the map itself is what is required in this case. These scans are then georectified, meaning that the corners of the map or key geospatial locations are set to known coordinates. By doing this, the image begins to shift into position over where it is located in the real world and thus can be utilized by a GPS or navigation system. Such practice has proven to be accurate at small scales, that is, where the map represents a land area that's very large, such as a county or the state level. Once you begin to zoom in to the street level, there can be issues with resolution and geospatial accuracy when compared to clean, clear, scalable vector data. Now, in order for us to describe how we would resolve the issues of street level accuracies, first we have to take a look at how beneficial vector data is when used in GPS navigation systems. Here we have I-95 just outside the University of Maine. The graphical display here represents a collection of many different vector data sets. Vector data is made up of 1. Points, such as the Black Bear Inn Conference Center and Suites. 2. Lines, such as I-95 and all other secondary roads shown in white. Or 3. Polygons, such as the Jeremiah Colburn Natural Area in green at the center, or the tanned colored areas making up the university grounds itself. At this particular scale, we could not properly use a navigation product that would be useful to the user. Here we have zoomed in to the proper display level of a navigation product. As you can see, the vector data sets scaled to the newer, larger scale. If this had been done with a raster image, and depending on the resolution of the image scanned, it could have dithered or pixelated, making key features look fuzzy. At this scale, vector line geometry is utilized to guide an animated display of the driver on the GPS unit. The center line of the road that is driven on is extracted. This geometry is not displayed, but used internally by the GPS unit itself. Additionally, the direction of traffic flow for each section of the road is also part of the data model. This is used to help calculate the route such that the unit does not send you down the wrong way on a one-way street.